Greetings. Assalamu alaikum. عسلامة الناس الكل. Donc greetings everyone, whatever you are. مرحبا بكم. So we will speak in English, but also in Arabic because we are in OWASP Tunisia chapter. And we have also our guest from Egypt, but OWASP Dubai Chapter Leader also. But welcome first to all our attendees. مرحبا بكم الناس الكل in Tunisia chapter event. So before we start, if you want to follow us through internet, فما donc الواسب تونيزيا اللي توا تشوفوا فيه واسب تونيزيا chapter in YouTube channel. You can go to our previous events and sessions, and you can subscribe and to follow the future one. وفما زادا our meetup group, OWASP Tunisia meetup group, so you can subscribe and join our community. Donc مرحبا بكم ناس الكل. Welcome to all the attendees. So today a warm welcome to our guest, our dear guest Ahmed Abdallah. So I present Ahmed such as software security consultant. He has an experience over 15 years in designing, implementing security systems and digital solutions. Ahmed Zeda is also international training, and recently OWASP Tunisia, Dubai Chapter Leader. So شرفنا أحمد. Donc مرحبا بيك
Thank you.
مبروك. So Ahmed, مرحبا بيك. Donc you will presenting mobile application security. So a presentation of the top 10, of course, WASP, but also with a demo. So all the attendees مرحبا بكم. You can ask questions, of course, in the chat room. And we will have a QA session at the end of the presentation. So can Ahmed, you agree with that? And you can note some comments below during the presentation if we have some links, some important links to share. So thank you very much to be here with us. مرحبا بك أحمد مرة أخرى.
شكرا جزيلا. Thank you so much for the kind invitation. Good morning, good evening, good afternoon, everyone. Based on wherever you are located at the world, it's a pleasure to be with you, and it's an honor to participate with the OWASP Tunisia chapter, presenting this short and intense session about OWASP Mobile Top 10 risks. We will be exploring the risks together, and we will be exploring how to mitigate from security point of view. And by the end, we will be exploring some of the tools that we usually use in the penetration testing cycle of mobile applications. Thank you so much for joining in. Thank you so much, Nihal, for this lovely intro. I guess we are good to go. We can get started right away.
Yes, we start.
All right. Awesome. Thank you so much for joining in. Okay, so during this session, we will be exploring building applications for users, not hackers. We will be focusing on the top 10 risks that are exposed and commonly found in the mobile applications. What we are going to cover, basically, we will be starting by covering the mobile application structure. And as I always say, when we understand how certain thing works, it's very easy to know the weaknesses, vulnerabilities, and how to secure. So, for example, when we are talking about web application security, you should expect that 80% of the time of the topic web application security is going to be regarding how web application works. Only 20% are going to be focusing on the security, because the major part in understanding both sides of security, which is offensive for attack and defensive, is understanding the subject. If you understand how actually mobile application works, directly the ideas related to the security are going to be very clear into your mind. So we will be talking about the mobile application structure, and then we are going to talk about the mobile application threats, and then we will be exploring the protection guides and best practices. And if you are interested in going ahead and starting your career or learning more about mobile application security, what would be the resources and how you can do that. Okay, so let's start by exploring the mobile application structure. What is the structure? What are the main components of a mobile application? And then we can identify what can go wrong with each of these parts. Before we start exploring this topic, I would like to introduce some misconcept that is very common while we are comparing mobile applications to web applications. Most of people think that mobile applications are more secure by nature than web application. Why that? Because in web application, you can right click and view the source. You can open some console, you can change, you can alter the application, you have URLs, you can see some of the parameters that are being submitted in the URL. So mobile application compared to web application are more close, more secure by nature. This is a misconcept. This is not true. Everything you can do on a web application is the same can be done on a mobile application. Both are sharing part of the code base at the client side. The full mobile application is on the mobile phone of the user, which is somehow accessible. The front end is also deployed and running within the browser and somehow accessible. So while we are exploring the mobile application structure, we will see what are the different parts that the users and attackers actually can be dealing with. Okay, so if we are considering this as a mobile device, within this mobile device, you have your mobile app. What's inside your mobile app? The mobile app has the binary, which is the code itself. It has some memory access. Part of this binary is loaded to the memory. It's assigning some variables. There are some data stored in the memory. And there is a storage where you are saving the in-app databases, the local databases, such as SQLite. You might be saving some files, XML or JSON files, some resources, images. So you are dealing with some kind of a storage. That's nice, okay? Not only this, every and each mobile application should be having another part, which is the backend. There is some kind of network and API communication. So you are accessing the backend, and for the backend, we are referring to it by a database. So there is database connection through the API. Okay, so this is the major components in any mobile application. It can look like this. So it looks very nice. What can go wrong? We are superheroes. The mobile application is super secure. What can go wrong? This is what might go wrong. Let's have a look one more time on this structure and see what can happen for each and every part of this. The binary inside your app can be reversed. So attackers might have an access to your binary, and they might be able to reverse engineer your binary and extract the source code. So you might be thinking, what would happen if you are saving some secrets hard-coded in plain text inside your binary, such as API keys, passwords? While reversing it, there is some kind of threat. The memory, what you are saving inside the memory. Some tools enables hackers to dump the memory, not only dump the variables in the memory, but also to interact with the application in real time, what we call inter-process communication, or for short IPC. What about the storage? Anything wrong might happen with the storage? Yes, definitely. Storage can be accessed through cables. I can extract whatever being saved on the storage, either through another application. So you are installing your application, you are saving some data to the storage. There is a private side of the storage, and there is public accessible part of the storage. If your application is saving some data publicly on the storage, other applications installed on the same device can be accessing it as well. Not only this, by the end of the day, your mobile phone can be lost. So someone might have physical access to your mobile application. They might be able to access the storage. They might be able to extract the logs and see what's happening inside. Not only this, the network and the API communication with the backend can be intercepted. So if you are sending something from your mobile application to the backend, this can be intercepted, and also it can be altered in both directions. So whatever your mobile application is submitting to the API, an attacker might be changing that, and whatever is being submitted back from the backend to your mobile application, it also can be intercepted and it can be changed and altered. So whatever you are receiving on the back end from your mobile app should not be 100% trusted, because that request might not be originally sent from your mobile app. It might be changed, and the same, whatever is submitted from the back end to your mobile application should not be 100% trusted, because it might be altered in between. Is it done? Not yet. The backend API, actually, it has another family of threats, but actually this is something that we cover in another session where we are talking about OWASP top 10 for APIs. Now we are talking about OWASP top 10 for mobile applications, so we will be focusing mainly on what might go wrong with the mobile application. So yeah, you can see that you have certain parts inside your app. Each and every part has its own source of threats. Mainly, or most likely, when we give this introduction about what can go wrong with the mobile app, we get some similar reaction from most of people. Yeah, really? Yeah, that's right. Yeah, lots of things actually can go wrong with this closed mobile app installed on your device. So now we are going to discover the top 10 threats created or documented by OWASP for the mobile applications. What can go wrong? Okay, so these are the top 10 risks that we should keep in mind while building a mobile app. And also, this is what we need to keep in mind while validating and verifying the security of any mobile application we are trying to assess its security. Improper platform usage, insecure data storage, insecure communication, insecure authentication, insufficient cryptography, insecure authorization. So we have authentication and authorization, client code quality, code tampering, reverse engineering, and extra functions. What are these different aspects? We will be talking about them one by one. Okay. So what do we mean by improper platform usage, and why is it the first one? When we are building a mobile app, we are bringing in our own logic, but we are using the built-in features in the platform. And here in the platform, we are referring to two different kinds of dependencies. If you are building your mobile app, you are definitely building this mobile app on top of either your operating system directly, which is iOS and Android, or you might be using another platform intermediator between your application and the application that you are building. So you might be using some frameworks such as React Native or Flutter, something else to help you building your mobile app. In all cases, these platforms, and if we are focusing on the operating system, the iOS and Android, they are providing you with some features for ensuring the security of your mobile app. For example, I will be talking about something like the keychain. Your mobile application platforms, the operating system, are providing you with a certain API for storing secure applications. If you are interested in saving some secret key, API key, username, and password, you have something called keychain, which is an encrypted part managed by the operating system. So the operating system is managing the encryption of it. It encrypts and decrypts its data using a certain key. So the ability of building your mobile app to utilize this security feature is very important. Okay. let's see what's going to happen if we did not utilize it. What would happen if we applied this risk? So we did not use that. What's going to happen? You might have a possibility to deal with a mobile application that's saving secrets or critical information outside of the keychain, so they might be accessible in plain text. This can be a risk. Or you might be using or putting them inside your keychain, but the secret, the key to the keychain, the encryption key, might not be saved securely. So someone might have an access to that key and then access the keychain. So if you are not understanding the security features provided from the mobile platform, you might end up either missing them and start working in some workaround, doing something yourself, so it might not be implemented at the same quality as what's implemented already in the Android and the iOS, or you might be using what's implemented, but you are not using it the correct way. You are not building it using the recommended and the best practices. This one and this threat, it's number one, and it has lots of other subtypes. It's very generic. So at any moment, if you are not understanding the security features of the platform and you are using them in some incorrect way, this actually can put your application into that kind of risk. So this is the first one. The second one, insecure data storage. We have been just talking about this in a moment. Insecure data storage might mean that you might be saving some of your application on a publicly accessible storage rather than private accessible storage. You might be saving some data in plain text while it should be saved as encrypted data. So you might be either implementing your own encryption using the library, definitely, or you can be saving them inside your keychain, which is the secret place of the operating system. Because if you didn't do so, your storage or the data on the storage might be exposed to the external, and attackers might have access to it. And here we have a very important note, and we are always receive this question. Let's say that I have an app on my mobile phone, and this app contains my data. And this data is not saved securely. They are being saved on a public storage, or they are being saved on plain storage. Now, who can access this data? By the end of the day, it's my data on my app on my phone. So no one is going to access it. Some people start thinking like that. But actually, this is not true. As we mentioned, this mobile phone can get lost. So what's going to happen in that case? Anyone who finds this mobile phone can access this data. Not only this, your mobile phone, and this is very important thing to consider when we are talking about the security of a mobile app, the limits or the perimeter of the mobile app, not the full mobile, but the mobile app itself. In other words, you are not trying to protect your mobile app data from the external world, but actually you have other threats coming from the same phone. You might have some, you are installing your data. For example, you have installed your banking application on your mobile phone, and you have downloaded some offers app or some game. What's going to happen if that game app was vulnerable? Or in its the developer who created this mobile app has placed the backdoor inside this app. In this case, you will be ending up by having an app with a very important data next to another attacked or compromised app. If this app could have an access to your insecurely data storage inside your important app, it's going to be a major threat. This is why the responsibility of saving the data securely in the mobile app is very important, and the app should be aware of securing the data and keeping it private, not only from leaking it outside the mobile phone, but also from other mobile apps that might be installed on the same phone. So this isolation is very important. By default, the operating system tried to make this isolation, but if you violated some of the rules and without knowing it, saved some data on a publicly accessible storage, the mobile operating system is not going to help you with that. So the way you are storing the data, how you are storing it, when you should encrypt, where to save the keys is very important, and this is what's maintained in the second OWASP security threat. Number 3, insecure communication. This is focusing on the link between your mobile app and the backend. What's going to happen if someone could intercept this traffic? And here we are talking about 2 different kinds of interception. So, for example, we are sitting in a lobby, we are sitting in a coffee shop, and you are using your mobile app to communicate with the server, and I am, as a third party, try to play man-in-the-middle attack to intercept the traffic between your mobile app and the server. This is some consequences of the insecure communication. But not only this, there is another threat. So let's say that as an attacker, I have downloaded the mobile app on my mobile phone, and I am communicating to the backend. Is there any harm that might happen if I intercepted my own traffic? Think of it. Let's compare these 2 scenarios. I'm an attacker, and I'm trying to intercept the traffic from your mobile phone to the backend. This is definitely a threat. There is some damage that might happen in that case. But what about the other case? If I am an attacker, I'm trying to intercept the traffic from my mobile phone to the backend. In that case, we might be thinking that there is nothing might happen. There is nothing wrong, because actually the data being flown is what I'm entering on the mobile app as an attacker. So what I'm seeing on the link is nothing new. I'm submitting a request on the mobile app, and this request is being sent, so I'm intercepting that. But there is actually other drawbacks for this. For example, when I'm trying to register an app, and this is a real case that happened to me when I was doing some penetration testing on a mobile app, I had a registration form. I tried to enter my data to register, and then I hit register button, and I intercepted the traffic to see what is being submitted to the backend. While looking at this request, I have found extra fields was added by the mobile application to the request before it's being received by the backend. One of these fields was a flag Boolean called isAdmin. This field definitely is not showing on the screen, but actually it was added by the mobile app. I could see it after intercepting the traffic. Now you can imagine what I can do with this flag. It's very simple. Furthermore, one other mobile app I was trying to work on, and this mobile app, it had no registration. I couldn't, as an end user, register. It was enterprise application. So someone from the HR should be registering and adding an account for me, and then I can log in. So I cannot register, and I need to log in to the application to see the different aspects of it. So what I have done, I have entered the wrong username and password. The requests have been submitted to the backend. Definitely, I got an error that I cannot log in, but because the error was very obvious and it contained only one flag called login false, altering this flag made the mobile app think that it's getting a success from the backend. So the mobile app revealed the rest part of the app. So I was logged in. From that part, I could see the other functionalities. I could submit other requests. So ensuring that the communication is secure, ensuring that the communication is not tampered, it's a very important aspect of the mobile application as well. Number 4, insecure authentication. What would happen if insecure authentication happens? What would happen if the application is not strongly trying to identify the user? Multiple things might happen. Another users might be able to access the application. So for example, it's, and we can say that most of social media applications, they are trying to keep your authentication very easy. So if your mobile phone got lost and you have Facebook or Instagram or Snapchat, for example, logged in, you will find that the attacker will be able to access your data. So the mobile application is not enforcing continuous authentication. Unlike what happened in other applications like banking apps, for example, you cannot maintain the same session for a long time. So is it secure, insecure? It depends on the category of the application. If you are dealing with a critical application, you should limit the session time. You should enforce multiple ways of authentication, or you should enforce the login one more time. Furthermore, your application should not be allowing weak ways of the authentication, like short passwords, passwords with repeated numbers, passwords that does not contain certain criteria, and more oftenly applying or adding the biometrics authentication. The OTP authentication is going to be very helpful to ensure that the authentication of your app is well implemented. Number 5, insufficient cryptography. And actually for the cryptography, we have multiple layers. We have multiple issues in here. So cryptography might be not enough. It might be implemented in an insecure way. So for example, you are submitting some data over the network. Is the network channel encrypted or not? Are you using HTTP or HTTPS? This is one of the questions. You are saving some data on the storage. Is this data saved encrypted or not? Even if it is saved on the private storage. Why is that? Because if your mobile got lost, there are some manners to extract both data on the public and on the private as well. Other category of issues related to the cryptography as well is the key management, how you are dealing with the key. So for example, one of the applications or one of the issues that we have found at one of the applications, it was using a similar or the same data encryption key for all users. So for myself, as a penetration tester, I could extract the encryption key from my mobile application. This encryption key is going to be used for other users as well. So if I got access to their storage, I will be able to decrypt it. So reusing the same encryption key, saving the encryption key in insecure way, not encrypting whatever needs to be encrypted. All these issues actually are grouped under the insufficient cryptography. It's very important. And one very important note that we should keep in mind while we are dealing or thinking of cryptography is that it's always recommended not to reinvent the wheel in the cryptography. Some people start thinking that I will implement my own cryptographic library. It's something that requires to think twice about it, because actually if you are not 100% sure about the strength of the cryptography algorithm that you are implementing, in that case you might be putting your application at risk. Cryptography is being referred to as a very important threat. It's very commonly used, and it's getting even higher rank at the web OWASP top 10 ranking. So cryptography is very important nowadays. Okay, number 6, insecure authorization. Number 4, we talked about insecure authentication, which is the ability of the app to identify the user. So how strong the app will be able to tell if this is Ahmed or not. After the app could identify the user, which is authentication, then we come to the authorization part. what can Ahmed do? Is Ahmed a normal user? Is he an HR employee? Is he a guest? Is he a client? Is he an admin? So what different parts can be accessed through this application is what authorization is all about. And it happens a lot to see that mobile app, in order to keep the code base simpler and consistent, you might find that the same mobile app used by the guest is the same used by the employee, is the same used by the admin. And the difference is in the authorization. So if you logged in as a normal user, you will be able to see part of the application. If you logged in as an employee, you will see another part. If you logged in as an admin, you will be seeing a third part. And this is fine. I'm not saying that this is wrong, but I'm saying that in this case, you should be paying lots of attention to the authorization, because in the same app, you are providing different access levels. And authorization is all about the access levels. If that was not correctly implemented, you might find some user able to access the space of other users by either changing something inside the storage, by changing something or seeing some extra data coming from the logs, through reversing, as we are going to see later on. So if you are trying to, and this is the most case, you are implementing the application for different levels of the users, and if you couldn't well split their privileges, you will be facing this issue, which is insecure authorization. I know you might be having some or trying to build up some questions so far. We will be having a QA session by the end, so just write down your questions. We will be getting back to that very soon. Okay, client code quality. Why we should care. Does it make any difference if the code was written in a good way or in a bad way? Is there any vulnerabilities might emerge from the way the code was being implemented? Yes, definitely. When we are talking about client code quality, we are talking about the quality of the code that, for example, testing the age conditions, or we call it the corner conditions. For example, you are defining a form, there is a screen where the user is trying to input certain name, a string. So this string might be an email, and you expect that the user will be putting here like 50 character long. What's going to happen if the user have put 5,000 characters in that field? If you are not sure how your application is going to behave, it's a threat. If I'm not sure how my application is going to behave, in itself, it's a threat. Why is that? Because I might be suffering from buffer overflows. What's going to happen if there is buffer overflow happening because the user has flooded my application with lots of inputs? Different things might happen. He might be corrupting the memory. He might be able to access other parts of the memory. He might be crashing the application. And there is a famous thing that happened a couple of times, basically for iOS, and you might be searching for that if you would like. It was like 3 years back that certain Chinese character was not supported if it was being submitted as an input in the iOS. So it was, you can search YouTube for this title, which is crash anyone's iPhone by sending single character. So if you submitted this character over WhatsApp to anyone, because this character is not mapped, or it's mapped to some other ASCII code that results in buffer overflow, you will find the whole mobile phone actually restarts. So this is a corner case that was not covered. So if you are facing any kind of these issues, that will be the threat, which is number 7, that addresses what you are actually missing. Number 8, code tampering. And this is related to the ability of attackers to change some part of your code. What does this mean? In other words, how easy it is for me, for example, to have your mobile phone and replace the binary of the WhatsApp with another version of the WhatsApp. How easy for me to change some part of the WhatsApp. How easy for me to, for example, change some JSON file that contains the URL for a certain app. And it's a very common practice. We see this a lot, that the application, the binary is a part, and there is another part or another set of files that holds the configuration of this mobile app. What's going to happen if an attacker could, by either direct access to your mobile phone or by accessing to this storage through a malicious or compromised app, what's going to happen if they could replace these files, for example, which contains the APIs, by another file that contains other links? In that case, your application will be connected to the attacker backend rather than the main one. How strict your application is and how many controls you are including in your mobile app to ensure the health and the authenticity of your mobile app over time, it's very important. How we can do that? We have multiple ways of signing the application, continuously checking or verifying the checksum of the app. So we will be able to ensure if there is something changing, there is something that attackers can be adding, someone has changed something. Someone has changed something in your mobile app. It's very important to keep that in mind. Am I using with, I'm dealing with the original form of my mobile app or not? And there is another attack vector that actually is related to the code tampering as well, which is called the supply chain attack. Attackers are trying from time to time to implement another batched or applications with backdoor. So they get the original version, for example, of WhatsApp or Messenger, and they try to patch it, add a backdoor to it, and they are trying to publish it on another alternative servers, telling you that actually this is WhatsApp Gold, this is WhatsApp the Dark Knight, any other versions of the mobile app that we are dealing with, and they are motivating you to enable installing apps from unknown sources on Android or doing this through jailbroken iOS devices. So once you install these applications are not the actual or the original, so they are changing the code. So adding tamper detection inside your mobile app is very important. These practices actually, they are not very common because most of people are not still aware of that. Number 9, reverse engineering. And this is considering or focusing on how easy for attackers to reverse engineering the binary and extract the normal code. So this one is one of the hardest ones to be mitigated, because by the end of the day, your mobile app is installed, it's on the platforms, they are being installed locally on the mobile phone of users/hackers, so they will be able to access this content. But how can we ensure that my application is not easily reversed? Anyone can reverse the mobile application, but we are trying to use some kinds of obfuscation. What's meant by obfuscation? After you write your code, you can run obfuscation tool. What this obfuscation tool is doing, this obfuscation tool is trying to generate random classes, generate random methods, change the readable names of your functions and methods to random strings. So instead of having a method called login API or login controller, they will be calling it xv3_k30, and it's going to change it everywhere. So this is what we mean by obfuscation. So in order to reduce the threat of the reverse engineering, we are trying to obfuscate the code in order to reduce the previous threat, which was number 8, which is tampering the code. We are trying to sign our application and keep verifying and validating the checksum of our binders. Okay. The last one, number 10. Adding more functionalities to your application. It's happening a lot. Adding more functionalities, adding more data. I have been, one more time, I was performing a mobile application penetration test on certain app, and I found that the login, which should return by true or false, actually it was, or I'm sorry, it was not the login, it was the profile page. The API which returning the data for the profile, which should return the image, first name, last name, and some contact details. These data are being exported from the users table. So because the back end and the front end, the mobile application users, were not aware of this threat, they were actually getting everything from the table of users and just sending it back to the mobile app, including the plain text password. Actually, I did not have an access to the user password. I could tamper with the session and access their token. So I submitted the request to view the profile, and I found that the profile API is giving me back the password. So the mobile app actually gave me a continuous access rather than the temporary access that I have by tampering the session. So adding more functionality inside your mobile app, adding, as I have been mentioning, keeping the admin part inside an application that's going to be used by normal user, or keeping at least the API endpoints of the admin inside an application that's going to be used by end user, just because we think that the end user is going to be limited to certain screens and they will not be able to access other parts. It's not true. By the end of the day, whatever you are adding inside your application, it might be accessible some way or another. So they might be accessing it through the reverse engineering. They might be accessing it by using some flaw or some weakness in the authorization. They might be accessing what you are adding in your application somehow. So keeping the application with only the required functionalities is very important. And if we didn't do so, we will be getting imposed to this risk, which is number 10. So that was the 10 risks documented by OWASP. These are the top 10. They are not the only risks that mobile application can suffer of, but these are the top 10. So what we are going to do next, we are going to talk about the protection and the guides and some of the best practices. At the same time, OWASP is trying all the time to provide what are the risks, what are the threats, how to identify them, and also they are providing guides that we should be considering most of time in order to ensure the security of our mobile apps. So we have in OWASP 2 major guides that you might be interested in viewing, which is mobile security testing guide and the mobile application security verification standard. What are these? What are the differences? The mobile security testing guide is the guide we use as penetration testers to ensure that we have covered all the different aspects of the mobile application from a security point of view. So as a mobile application penetration tester, the MSTG is going to be my major guide. And these guides actually are underrated. They are very important. They contain very important and very useful and helpful stuff. The mobile security testing guide is very helpful. It's available on OWASP for free to download. It's open source, definitely. And the other guide, which is the mobile application security verification standard, it's helpful not for the penetration tester, but it's helpful for design point of view. So while we are implementing our application. And even before we start designing the app, we can visit and review this verification standard guide to ensure, have we built in the security in our mobile app from the beginning or not? Because in most of cases, if we are not considering the security while we are designing and implementing our app, and we are just focusing on building or applying penetration testing before we go live, we will find that the penetration testing stage, which is explained in the mobile security testing guide, is telling us actually you need to change certain things in the previous stages. So in most of cases, it's too late or it's too expensive to get back to these stages to apply. So visiting the security verification standard from the beginning while we are designing the app is going to save us much time when it comes to the mobile security testing. So these are the major things that you might be considering. And for short, if we would like to summarize the major things that we need to consider while we are dealing with a mobile app, we are trying most of time to reduce the application login. You will find most of time that developers are trying to debug their apps. They would like to ensure that everything is working fine, so they keep logging, and some of these logs actually contains very sensitive information. We keep that in mind. Try to secure the local data storage. Never assume that my app is the only one who is accessing the storage. This is not true. This is true only in the happy scenario. But in other cases, some other apps, some other attackers might be able to access the local storage. So you try to keep things as secure as possible. Always validate user input, either on the mobile app itself, on the API, from the mobile to the backend, from the backend to the API. Always ensure that what you are sending and what you are receiving is clean and valid, and do never trust the source. Never say that it's coming from the backend, so it's trusted. It's being, or the backend say that it's coming from the mobile phone, it's trusted. It's not this way. Try to sign your application, and thanks to the mobile application platforms, they enforce the code signing. Always use HTTPS and certificate pinning for secure communication. One note, what's certificate pinning? Certificate pinning means that your mobile app is not going to connect to the backend if it's not submitting a certain certificate. So for example, the attacker will not be able in that case to install an intermediator. The attacker will not be able to behave as the backend because the attacker does not have the certificate of your backend servers. So your app will only be talking to your legitimate backend without any intermediators in between, and the data is going to be submitted encrypted. So even if the user or the attacker could implement man-in-the-middle attack, he will be viewing your data from your mobile app to the backend as encrypted, not plain. Think twice about authentication and authorization, actually. In most of cases, we see that people are, or developers are implementing authentication and authorization in a bad way. One very quick example I have seen, the application was implementing authentication as authentication wall. So you have to provide username and password to access the application. But once you access the application, all the other screens are submitting requests to the backend unauthenticated, which means I can have my own username and password to log into the app. And once I could log into the app, I can submit requests to the backend to access other users' data, because these other later requests are not authenticated. So this is very important. And also thinking twice about authorization. Are we relying on good factors for authorization? Are we implementing an exclusive access control, or someone might be able to access someone else's data, violating the authorization? This is also something that we need to remember. So if you are interested and you would like to get started, what would be the major sources that you can be doing it? The first thing that you need to keep in mind is understand how things works. So understanding the mobile application is the basic point in becoming a mobile application security expert. Understanding how web application works is the major point in becoming web application security expert. So understanding how it works is very important. Getting familiar with tools and guides, this is the second one. And in most of cases, we see people start by the second step and ignore the first one. They try to ask about the tools. What are the tools? What should I do? But actually, once you use the tools without understanding how it works, you will not be able to utilize the tool. You will not be able to understand the reports you are getting from the tools. So tools and guides are going to be very helpful after you understand how actually it works. The third thing is getting practice. Try to practice lots and lots of time so you keep adding new skills, and your skills will become doing things without thinking about them. And this is what differentiates an expert from a beginner. Beginner is thinking about everything, exhausting their minds about thinking about all the details. Experts, because they have practiced a lot, they will be solving major number of problems without thinking because they have pre-built patterns in their minds through practicing. So they will be only utilizing their thinking and their innovative in solving the real complex problems, not about solving the common or redundancy problems. So practicing is putting you at this stage. So this is what we try to share with you during these slides. I think we still have some time for going through a quick demo and having some question answers. If we have some question answers, we can answer first and then we can go with the demo. What do you think?
We can move to a practical part and
then we have the Q&A.
Yeah, all the questions.
Sure.
I think.
Yeah. Okay. Sounds great. Okay. So let me share my screen. So the tool that we are going to talk about, we are actually going to talk about two tools. One of them we are using for
Ahmed, just
dynamic security analysis. Yes, please.
We are not showing something now.
Oh, yes. I'm loading the tool right now.
Okay.
Now you can see.
Yes.
Okay, so this is the tool that we are going to see. It's called MobSF, which stands for Mobile Security Framework. It's a web application tool that's available as a container. So I'm running it on top of Docker. You can find it in here. I'm going to share the link as well. So how does it simply work? Actually, after pulling the image and starting it, you will be able to work on it through this interface. By default, it listens for port 8000. Then you start by uploading the application file. So how do we obtain the application file? Actually, we have lots of different sources. So if you are downloading some app, and I'm going to talk about Android specifically, if you have an app installed on your mobile phone, you can actually get what's installed or extract the APKs. You can also use some websites like APK Pure. Such a website is a good place where you can download most or lots of applications as an APK. So, for example, we are going to download a generic app. Let's try this with Instagram. Now I'm going to download the APK of Instagram, and then we are going to upload it to the tool. It's being downloaded right now. And then we are going to upload it to the tool, and then we are going to see what the tool are going to show us about it. Now the APK is being uploaded, and now the analysis are going to start. What we are seeing is what we call the static application security test, or for short, SAST. What do we mean by that? We mean that the application or the tool we are using is trying to give us some insights about the security or the weaknesses inside this app, not only the weaknesses, but also the features. So it might be showing you the back-end servers, the URLs, the package name, every information that might be useful in the next stages. It might be showing you what kind of local storage are being used, how many screens are in this app. So the static application security test is giving you better insight about the application you are dealing with through the analysis that happens on the APK itself. So now it's doing this analysis. After seeing that report, you start building a better understanding of the app. Then you go to the second stage, which is DAST. So the first stage is SAST, Static Application Security Testing, and then you go to the DAST, which is Dynamic Application Security Testing. What happens in DAST? In DAST, we can be using a tool like OWASP Zap. What's OWASP Zap and how does it work? OWASP Zap works as an intermediator. You can install OWASP Zap between your mobile phone and the backend, or between a simulator and your backend. Zap is going basically to show you the traffic that's being submitted from your mobile app to the backend. So you will be able to see all the requests, you will be able to alter them, and you will be able to see the response getting back and also alter the response from the backend to the front end. So that Zap is giving you the ability to interact with the traffic. Another tool that we might be interested in using as well, I'm going to show you right now. Let's see the analysis if it is already happened. Another tool that you might be interested in investigating as well, it's called FREDA. FREDA is an instrumentation tool. What does it happen? How FREDA actually works? FREDA is giving you the ability to interact with the mobile application in real time through the memory. So you might be able to inject some callers inside the APK or inside the reverse engineered app, and then you can interact with the app itself. So you can be submitting some requests, you might be calling some functions from your mobile application. It's basically used for cracking the internal structure of the app. So Frida as well is a very interesting tool, but actually you can use it in the third stage. So basically, at the beginning, you might be looking at static code analysis, and then you start learning more about how the application is communicating with the back end through Zap. And finally, if you would like to go even deeper and start changing the way the application is running in the real time, you might be using Freda. We usually do this after the reverse engineering. Okay. So as this is still analyzing the app, we might be talking about another possibility or another tool, which is the Java decompilers. Java decompiler is using a tool. It's called APK tool. APK tool is an application installed by default on, or it comes pre-integrated with Kali Linux and other Linux distributions as well. It's being used for reverse engineering the application and extracting the source code, basically for Android apps. You might be doing it on the mobile, on your command line locally, or you might be uploading your APK to this website. It's going to extract or reverse engineering the APK and extract the source code and show it to you as plain text. And this is giving us the meaning or the feeling why it's very important to rely on or to implement some kind of obfuscation tools. So you might be decompiling an APK, and then you can start going through the source code. Not only this, you can change certain parts of the source code and recompile it again, so you got a batched binary. And this is very important because some people, the report that we are getting here, we will be getting here from the mob SF, is actually showing you all the details that you might find from viewing the source code manually. So why should I reverse engineer the app and view the source code to start extract information? Such a tool is going to do exactly the same in an automated way. But actually, in the APK, because you have decompiled and you have the source code, you might go and start changing certain parts of the app and then recompile it again and deploy it on your mobile app. And here comes the question, what would be the value? I have batched only one copy of this app, which is on mobile app, on my mobile phone. Other apps in the world are still original, but some other things you can learn with this, which is, for example, if the mobile app is not letting you to intercept the traffic between the mobile app and the backend, because, for example, it's using certificate binning. You can decompile, view the source, remove the certificate binning verification part, recompile the APK one more time and implement it or downloading it on your mobile phone. Now you have a batched version that does not verify the certificate binning, where you can implement your intermediator, which is OWASP Zap, so you will be able to intercept the traffic and alter it as well. Okay, so hopefully this is done. It's not done yet. Okay, so I think we can have some questions until the analysis is done. What do you think?
Okay, so I share the first question.
Yes, please.
So first question from Tawfiq, Muhammad Tawfiq. So what's the life cycle process steps to test pen testing and vulnerability security for mobile app projects, please?
Okay, so thank you so much, Muhammad. What is the life cycle process steps to test pen testing and vulnerability security? Okay, very good. Thank you so much. Okay, so the life cycle of the pen test is we usually go for the pen test at the stage before the releasing. So before each release, we go through a penetration testing cycle, which we referred here to the dynamic analysis. So we have the application, we interact with the application on different levels to ensure the security. But when we are ensuring or looking at the complete life cycle, you will find that security should not be limited to this penetration testing stage, which is just before the releasing. Security actually should be implemented even before that. Now let me show this with you, which is the DevOps cycle and the life cycle versus the DevSecOps. Here, yeah. So if we are looking at this cycle, you will find that this is the normal cycle. We plan, we code, we build, we test, and then we release. Usually, in most of time, before the release here or during the test, we apply the penetration testing. So to answer your question, where the penetration testing happens, it happens here in this stage. But the security cycle should not only be limited to this stage, because as you can see, in the modern approach of the DevSecOps, we need to make the security a governance layer on all the other aspects. So for example, when we are planning for the project, we are taking lots of decisions about how the application is going to be implemented. For example, we are taking decisions related to the cryptography. We are taking decisions relating to how the authentication and authorizations are going to be implemented. All this happens in the planning. So if the planning phase did not include some eye from the security, we might be missing some security constraints or security components. So while we are planning the application from a functionality point of view and from security point of view. When it comes to the coding, we should implement or impose some stages or some steps for secure code review. And most importantly, we should include during the coding some awareness sessions. We should be talking to the developers how they should maintain the good quality of the code from a security point of view. When we are trying to build the application, this is where we implement the signing stage. This is where we implement the obfuscation. So if we are not adding this in the penetration testing, it might be too late to get back or more costly to get back and change these stages. So the answer to your question, where the penetration testing happens, it happens in this stage, but where the security should be involved, it should actually be involved in all the different stages. Hope I have answered your question.
Thank you, Ahmed. We follow Tawfiq again. What is the potential use case scenario for mobile application projects while the pen testing and security check-in tests?
Okay, thank you so much. It's another good question. You are asking about the potential use cases scenarios for a mobile app project during the pen test and security check-in tests. Okay, very good. Usually we start considering different parts of the application if we are referring to the first or second or third slide of our presentation, which are the binary. Is the binary secure enough? What happens in the memory in the real time? What about the storage? And what happens on the internet, the traffic between the mobile app and the backend, in addition to ensuring the security of all the different forms. So we start by during the penetration testing stage, we start by going through the normal user stories that the user is doing, and we start seeing if the user can manipulate any of the inputs from a user point of view, and then we start simulating other use cases that might be implemented by more sophisticated hackers, either by intercepting the traffic, by changing and batching the binary, or by trying to access the storage. So these are the major parts that we might be including in our site. Hope I have answered your question. If you have any further follow-up questions, please let me know.
Okay, so Tawfiq has many questions.
Yes, of course. Yeah,
we,
yeah.
We
Most
follow.
of them. Yes, please.
So,
can we deploy OWASP tool? Yes, please, now.
Can we deploy OWASP tool into a virtual machine via a visor like VM or VirtualBox in order to test the mobile app project's program code, save it via Android?
Yes, yes, the answer is definitely yes. We have two versions of the mobile of Zap. So you can either install Zap as on a mobile app. You can definitely do that. Sorry, I'm sorry. You can use it as a virtual machine, either VMware or hypervisor or VirtualBox, as you mentioned. And you have another version of Zap, which is called the headless version of Zap. You can actually install it and run it through Docker. So you might be using it as command line. It's headless. It does not contain GUI. So it's going to be used through Docker. So you can install it on Docker and keep it intermediate or as a proxy for your mobile phone. So the mobile application traffic is going to pass through it.
Following?
Yes, please.
So which security test type, unitary, modular, functional integration to apply for the mobile app project, pen testing and security use case to check in the program code? So he's asking the security type, test type to apply.
Okay, I got your point. Usually the pen test, if we are referring the pen test to the normal mobile app, to the normal kinds of tests, it's going to be modular, because you are actually not limited to a certain functionality. You are exploring or trying to ensure the security of the whole module, and in the same time you are expanding it to the system test as well. So it can be considered as modular if you are applying this per release. So each release you are testing the module that you are going to release, or you might be considering it as a system if you are doing it at whole before going to the live stage.
Okay, so Ludonzo?
Yes, please.
Lunozzo. Hi, Lunozzo. Are there common tools to explore wireless security in mobile devices?
Yes. So you need to explore. Yeah, actually, this is common, but in this case, they are not considered as part of the mobile application security. It's considered as part of the mobile device security to ensure how it's dealing with the NFC, the Bluetooth, the Wi-Fi. So it's more into the device security than the mobile application security.
Than the code itself.
Yes.
So,
yeah, that's right. That's absolutely right.
What tools could we use Karima? What tools could we use to pen test backend of mobile app? This is the main part of the session.
Yes. Thank you so much, Karima, for this question. Actually, one of the major tools that we use for testing the backend part is Zap, because Zap is focusing on the integration part between the back end and the front end. So once you implement Zap in between, you have a full visibility about what's happening on the back end. So you start testing and attacking the back end through Zap.
Okay, so we follow?
Yeah, yes, please.
So Tawfiq and then Amani. So what are the other IDE and software tools do you frequently use for your daily security test?
Okay. So on daily basis, if you are pen testing mobile app, you should have the same IDE for the developer. So for example, for mobile application, for Android, you should have an access to, or you should have your Android Studio installed. In addition to the security tools like the MobSF and Zap. So you can say that these are the major three tools that we will be using most of the time. In addition to, on personal preference, in addition to Visual Studio Code, I use it basically for writing scripts to automate certain tasks during the penetration test.
Okay, so I think Many is the same flow question. We talked about
I guess so.
environment, yes.
Yes, so it's basically you should have the Android Studio and the Android SDK. Most likely you might be using an emulator that you create inside your Android Studio, or you might be using a mobile phone for penetration testing. So it's your IDE, Android Studio, Zap, MobSF, and your preference of IDE. For me, I use Visual Studio Code for writing scripts to automate.
Very clear.
Yeah, thank you.
I think the security framework ready now.
Mm-hmm. Yeah, actually, I have this sample report to go through. So once you go through your application, you will be finding something like this. It's showing you the severity and it's showing you certain information. So it starts by the file information, the size, the MD5s, which is the hashes that ensures if you are using the correct APK or it was tampered. It's showing you some app information and app components. Here you start identifying the internal structure of the app. How many activities, which are basically, you can refer to the activities as streams, how many services running in the background, and they are usually either doing some background activity, and then most of the time they are communicating with the back end. The receivers, which are the part of the app that receives or listens for certain notification. For example, some applications or most of applications are trying to receive the internet status connection, if it was down, if it was up. The providers, if they are publishing information, so what information they are consuming from the operating system. These receivers, what information they are providing to the operating systems are providers. And providers are one of the parts that commonly introduce a threat if you are trying to build multiple apps. So for example, some business rely on building two different apps, and both apps are being installed on the same device and they need to share information. So one of them introduces a receiver and the other one is introducing a provider. And anytime you are sharing, you will find that the attacker is very interested to join intermediate to create another receiver and to provide or to get the data as well. Exported activities, which are publicly accessible activities, it's something that you might be taking care of. So then it's talking about the certificate information, if the APK is signed or not. It's telling you that this APK is signed, which means it's not going to be easy to batch it or to change it and republish that, because if you did, the operating system is going to identify that this APK is not the original one. It's showing you some information about the APK. So all this information that we are seeing right now is not confidential. This is a very important thing to keep in mind. All this information are available just through the public or the basic analysis of the APK itself. So they are available. Anyone is downloading your app, you will be able to access all these data. Now it's showing you the application permissions, what this application can do on the mobile. And this might sound fine. For example, this application is reading phone status. That's fine. What would be a problem with this? It's changing the Wi-Fi multicast state. What might be wrong with that? It might actually need to do this. But the point is, if you are investigating a mobile app, and this mobile app will have certain dangerous permission, and you could batch this mobile app. It means that this backdoor that you are adding to the APK will have the same permissions on the phone. So if I could batch a mobile app because it's not signed, for example, and this mobile app have an access to the camera, to the storage, and to the microphone. Now I'm compromising a strong app, which is going to give me as an attacker an access to the mic, to the camera, to the local storage. So this is why we might be interested in viewing the permissions for this app. So the attackers, when they are trying to attack your mobile app, they might be trying to access the data inside this app, to access the back end, or even to access other apps on the same mobile phone. Attackers are not, they are not picky. Whatever they get, they take it and they start uploading to the next level. This app, it seemed that actually they just visited the permission page of the Android documentation and select all, copy paste, and they got all the apps available, which is okay. Okay, so the analysis, how the APK was built, the browsable activities, which are basically how you can integrate, or what are the applications that can be used for opening these kind of files. Okay, now let's pick some interesting stuff. Now this application is allowing clear text. It's a very high severity problem. If your application is allowing clear text, it means that you are making it piece of cake for any attacker to intercept and change the code. The traffic between the application and the pen test is going to be very simple. Activity is not protected. It means that from outside application, you can be accessing this. Launch mode is not standard. It means that the application or this activity can be launched from other application, which is another severity. For the code analysis, and this is another very important thing, it's showing you if there is any part that, or any activity or any class that might include sensitive information in plain text. How does it know it? If your code contain a variable called password, called the API key, called the username, so it's going to show you certain severity, and it's showing you that this was not found in a certain or in a single place. It was actually found in 4 different files. The good thing about this tool, about MobSF, is that it's compatible with OWASP Top 10. So it's showing you the severity, the CWE, which is coming from the MITRE database, and also it's showing you what is wrong referred to the OWASP Top 10. So it's showing you that this issue is raising the threat of M9, which is reverse engineering, and it should be mitigated if you build your application according to the verification standard guide. So according to the verification standard guide, storage section number 14, you will be notified that, or this guide is telling you that you shouldn't keep your password like this. Then it's showing you other sensitive information as well contained. And then it starts to check the domains. If any of the domains or the websites included inside this app, if any of these are known to be spreading malwares or no. And then it's showing you all the URLs that were included in this application. So you will be able to identify all the different endpoints. And from this, you might be integrating or trying to connect to the APIs directly through OWASP, through Postman, through command line. So you might be playing the role or simulating that you are the mobile app and start reaching them out. And then it's showing you if there is any trackers. Most likely, most of the applications, you will be using some trackers coming from Facebook, some from Google. So it's showing you what's happening. And this is only the guide. It's showing you the overall risk flag or the overall risk rank of this application or this APK. And it seems that this is, it contains some issues for certain parts and some other parts are not so bad. So that was a sample report coming from this tool, which is MobSF. And as we mentioned at the beginning, if I'm not aware with the internal structure of the app, if I'm not aware how the app actually works, I will not be able to make sense out of this report. Any question whatsoever? All good?
Thank you very much, Ahmed.
Thank you. Thank you. It's a pleasure. Thank you so much. I know that we are exceeding the allocated time, but I'm happy to be with you. And if we have further question, I'm happy also to answer that.
Yes.
Let we
have the last one.
Yes, please.
Guess, Tawfiq.
Yes.
How to determine the vulnerabilities, danger, risk degree level for a mobile app project program codes while the testing, the testing check in progress or
okay. Okay, very good. Thank you so much. Okay, so most likely, if you are referring to the testing guide, you will find a predefined risk level for each vulnerability. So if I found that there is a vulnerability which is leakage of sensitive information, and there is another vulnerability which is, for example, insecure or insufficient authorization, I will find that the risk of insecure authorization is higher than leaking sensitive information. And actually, this is maintained in the order of the top 10. So if I'm getting a vulnerability from the second type, it's higher risk than getting or finding a vulnerability from the 9th type, for example. And this is why you will find the lower items in the list, like reverse engineering, because, for example, it's something that does not have 100% mitigation. So if you found your application can be reverse engineered, it's actually a normal thing. We are just trying to ensure that it's not easily reverse engineered. Unlike, for example, authentication. If I found some issue for the authentication, this should be solved first.
Okay, so the last.
Yeah.
Not the least.
Sure.
Ons defense. Donc, hello. Yes. When an application asks permissions to use some resources, it's actually possible to reduce authorization bypass by restricting the permission?
Okay, thank you so much. Okay, so actually the permissions, the short answer is no. Short answer is no, because in most of cases you are just either providing the permission or revoking it. So for example, if you are providing your application with a permission to access your local storage or to access the photos and media, you are giving it a permission on the whole public storage, not on a specific stage. So actually it was even worse at the beginning because for example, for the Android apps, you had it was not that granular. So while you are installing the app, either you allowed and granted all the permissions or you don't install the app. Now it's getting better. So now you can enable certain permission and disable another permission. You can, after enabling a permission, you get back and revoke it. But so far, we did not reach to this level of granularity to give it an access, for example, to a certain stage of storage or to a certain group of contacts. But going through this awareness, the increase in the awareness of mobile application users of privacy and security issues, it's giving us good indication that maybe in the future we will be able to do what actually you have asked for.
Ready for another one?
Yes, of course.
Okay, let's talk about AI.
Okay, perfect. Okay, can we automate mobile application penetration testing and security pipelines process via DevOps and or through artificial intelligence? Thank you so much. Okay, so actually DevOps is coming to automate. So if I did not automate, I'm not having good penetration testing. So your question is 100% true, and we need to include the penetration testing within the DevOps cycle to make it DevSecOps. And in this case, we have automated the penetration testing through static analysis and dynamic analysis. So for example, this report that we could generate from some tool like MobSF, it can be fully automated. So every time you are publishing new portion of the code to the repo can be generating a request or submitting a request to the MobSF to generate a new version of the report. And it can also integrate with the headless version of OWASP Zap to build or to execute a number of predefined requests from the mobile application to the back end, and then you get automated results. So automating SAST and BAST is very important, and it's actually there. Including the artificial intelligence in place, it's something that we can say it's under development. We have some successful use cases for that, some tools, some commercial tools, definitely. They are using artificial intelligence to generate further requests. So for example, if you are designing your DAST, your automated DAST cycle by generating 100 requests to be submitted through Zap to the API and verifying the responses, and you are automating this to happen through your DevSecOps pipeline, you can introduce an AI that make this 100, 120, or 150. So the AI will be suggesting even more requests and even more tests to be included within the same automated lifecycle.
Thank you very much, Ahmed.
Thank you.
So, and also, if you have, we had previously our video about the mobile security application, the security verification standard testing guides, also to check, of course, with the test cases, some to automate the checklist, and to also check the health check in general and security check of mobile applications. So thank you very, very much, Ahmed, for your valuable contribution, and thank you for joining us.
Thank you so much. Thank you, Nal, for your generous invitation. Thank you so much, everyone who attended. Thank you for your time. It was a pleasure being with you. And yeah, hopefully to see you in upcoming sessions as well. So we might be, if you are interested, we might be working on having some other session where we are not talking about the theory, but we are just implementing some kind of penetration testing on a certain app through Zap, so we can see the DAST, how does it work. Lots of other actually ideas might be discussed in upcoming sessions. We will be in touch with you, and you have, I think, Nihal has shared everything about the chapter. You did, right?
Yeah, exactly.
Awesome. Yeah.
Thank you again, and thank you for our dear attendees. Thank you for your interaction, for asking some questions, for some very relevant questions. So thank you very much. Thank you again, Ahmed, and see you in another session. Thank you.
Thank you so much. It was a pleasure. Thank you so much. Have a great day. Thank you. Take care. Take care all. Bye.